The handouts we're going to do are called solving by factoring today. So I'm going to go over those two that you saw at the beginning. Sketch the graphs with a domain of -2 is less than x, and x is less than or equal to 3, and a range of -2 is less than y, and y is less than 5. Does everybody understand those symbols right there? Determine if the line is solid or dotted. Yeah. Okay. So really important when you look at that, go on the x-axis to -2, which is right here. I'm going to put an open circle right there, yes? And we're going to understand why it's an open circle. Doesn't have the bar underneath it that says including it. Yeah. And right there, go ahead and draw a dotted line. And then go to 3. And you notice on 3, is it an open or closed? Closed. And that'll be a solid line. Yeah? Okay. Sketch a graph with the domain of that. So right now, if you were just to sketch the graph with just the domain, the line would have to start somewhere over here and end somewhere over here, okay? But you got to keep into consideration it also has a range, okay? The range is how, because you could easily just draw a line from here to there with a domain of that, yeah? But the problem is you got to make sure it satisfies the condition of the range, okay? So do you understand why I'm not going to keep that graph that way? Yeah? Okay. All right, so now my range says go to the y-axis at -2, put a closed dot or an open dot? Closed dot. Okay, that's going to mean a solid line, okay? Now you guys already see I'm drawing the boundaries of where the graph's supposed to be inside. Then go to the y-axis at what number next? 5. Open or closed? Open dot, so therefore a dashed line. So there's many different answers you guys can draw for the response to this question, though, okay? As long as it starts, you can have it start up here. Would it be justifiable for me to put an open dot right there where those two dotted lines intersect? Yeah? Can I do this? Could I do that? Is the domain still from -2 to 3? Okay, is the range still from -2, including -2, to +5, not including 5? Yeah, that's one that you could have done. You also could have done something like this. Start here. Bam. Looks like it takes you to. You could have done something like that. Does that make sense? Yeah. You see, we can go all kinds of different ways here. So everybody's answer, as long as your graph started on the left, on the dashed line somewhere, and it was an open dot, and as long as your graph went either up or down to those two range values, and somewhere in between there was no gaps. And the reason why I say this is because if you would have put a gap here, let's say an open dot right there where it jumps, then it changes the domain and the range of it. If there's an open gap right there, like that dot I just put there, that means it's going there, but then right at that point where that x value and that y value meet, there's a discontinuity. It doesn't continue. Yeah. everybody okay with that one right there? There's a couple different ways you could have done that. All right. Does everybody see how you would sketch your graph for number 2 then? Yeah? Okay. Let me go to the next part. Use at least 2 methods to find the x-intercepts of the graphs of y equals 2x squared minus 5x minus 12. There's a couple different things you guys can do. Everybody have your graphing calculators? If you don't, can you grab one? Here's our graphing calculator. Alright, so we're going to type in this equation into our calculator, okay? So the equation is, notice it's y already by itself, so go ahead and type it into the calculator. Here. You hit the y equals button for those of you that are having trouble still inputting and using the graphing calculator. Really important. Make sure you come and see me. So 2x squared minus 5x minus 12. All right, as I type that in, is there anyone that has any questions on the typing it into the equation? All right, go ahead and hit your graph button. All right, does your screen look like mine? Yeah. Does everybody understand that the window that we're in, if I wanted to check what all these little marks mean, I would just hit the window button, and I'm all in increments of 1 with -10 to +10 on the x. And on the y's, I'm from increments of 1 from -10 to +10 on the y-axis. So really important that everybody know how to take advantage of the graphing calculator. Okay? All right. Do me a favor, go to the table of values. So in your table of values, can we find x-interception here? Does anybody see any? Just by looking at the table of values? What do you think, Rick? Do you see anything that tells you an x-intercept? No? Do you guys remember when I told you to get the y-intercept, let what equal what? Okay, to get the y-intercept, let x equal 0. You guys remember that? Yeah? How about to get the x-intercept? Let y equal 0. So I want you to look at the table of values. Look for any y value that's 0. What do you notice, Rick? You need a coordinate that has 4, 0. Does everybody see that coordinate on the table of values? Okay, that's an x-intercept, isn't it? At 4, 0. Can I figure out where the other one is? No, not when x 0. I want another x-intercept because you notice it was a quadratic equation. Go back to the graph. Is it true that that graph touches the x-axis twice? Does it? One of them is at 4, 0. You guys see it? It's right here. So at 4, 0, right there, there's one x-intercept. You see that other one is over here on the left of 0? So go ahead and see if you can look at the table of values and see if you can find the x-intercept to the left of 0. You notice I have to scroll to the negatives, and do you see it should have popped up already on the table of values? You notice it's not popping up though? There's another way you can do this, and it's an approximate value, all right? So do me a favor, go ahead and hit the graph button. Everybody with me? All right. Do you see all these options that you guys have up here? You guys see the Y equals window, zoom, trace, and graph button? Remember which one of those buttons can help you to figure out what the other x-intercept would be? The trace button. Ready to hit the trace button? And before you start moving anything, look at the screen real quick. You guys notice on the top is the equation. You see on the bottom, there's an x equals 0, y equals negative 12. Just real quick, 0 comma negative 12. If x is 0, that's your y-intercept. Yeah? You see that the y-intercept is down here below where the graph is actually, you can see it. So that means if I want to trace this parabola, let's go to the left. And it'll start to pop up. Do you guys see the blinking X popping up there? Yeah? Trace it up until you reach the x-axis. You notice you don't get a y value of 0 though. You're getting an approximate value which is about negative, it's going to be about negative 1.5 maybe. But remember, it's approximate value, right? Well, how do I do this algebraically so I can get an exact value? This is where I need to go over how do you guys do quadratic equation, how do you do factoring, how do you solve for the x-intercepts of the quadratic equation, okay? So, do you see how the calculator only gave me one of the x-intercepts? It didn't give me the other one exactly. So the calculator is only as good as you make it. At one point, though, the calculator might not give you an exact value. Yeah? So I want to make sure I show you guys how to use the calculator well, but at the same time, I'm going to show you some methods that will give you the solutions. Whenever you guys are asked for the x values on a quadratic, or they're asking you for the zeros, the solutions, the roots, all of those mean the same thing. Where does the graph touch the x-axis on a quadratic? Okay. When they're asking you on a polynomial function, where the zeros are is where will the graph touch the x-axis? Okay. All right. So let's go ahead and put you can keep the calculator, put it on the mode where you can do some multiplications and divisions so you can just check. All right. So does everybody see, we know one x-intercept, right? 4 comma 0. I need to get the other one, okay? So first thing I want to show you is factoring. I'm going to give you guys a separate sheet of paper where I want you to put down these notes for factoring, okay? Now, do any of you guys remember factoring? Did any of you guys ever use a method called the Xbox method? Do you remember hearing that? Yeah? Do you guys ever remember hearing something called the quadratic equation? Yeah? Okay. So factoring, there's different types of ways to factor out something. So can you put in your notes the word factoring for me real quick? And put in there, I'm just going to say just a general description of what the word factoring means. It's setting up a multiplication. Yeah. Here's the handout we're working on right now. We're taking notes on that one right now. All right, so factoring is setting up a multiplication. So when you factor something, that means you can set it up as a multiplication. For example, the number 25, if you factor 25 out, set it up 25 as a multiplication of two other numbers. So could two other numbers multiply to give you 25? 5 times 5? Everybody okay right there? Well, how about factoring a polynomial like this, 2x squared minus 5x minus 12? Can you set that up as two parentheses that multiply? And when they multiply, you do the FOIL method. You guys remember the FOIL method? They multiply and they give you this polynomial, yeah? So factoring, we got to set up some type of multiplication. So here are the tricks that I want you to remember. This is really ax squared plus bx plus c. A value represents 2. B value represents -5. And the C value represents the -12. Okay? A value, B value, and C value. All right. So, and you guys are taking notes on the graphing paper that I gave you guys right now? Now the method I'm going to show you is called the Xbox method. Some of you guys might remember that. So let's just do a general rule. The x, on the top of the x, you're going to multiply the ax squared times the b term. Close. I'm sorry, not times the b. I'm like, something doesn't fit right there. The ax squared times the c term. Can you fix that? Miracle. On the bottom, you write down what is the bx term. Okay? And then, does anybody remember what you do here? All right, so does everybody see where the two question marks are? Something, one of them has to, the top or the bottom is an addition of these two. Which one do you think it is? The bottom. The bottom has to be addition of these two numbers. The top has to be the multiplication of these two numbers. So the two question marks, bottoms are the, let me fix that real quick. Question marks have to add to give you the bottom. Does that make sense? And then when you figure out what those two numbers are, the question marks have to multiply to give you the top of the x. That make sense? Yeah. Bottom of dx, top of d. Okay. So everybody okay with me so far? Yeah. Now for those of you guys that just came in, you're doing these notes on your graphing paper, so some of the stuff you might have to go back and watch the video from the intro. Okay, so just jump in wherever we're at. Leave some space. Okay. All right, so we've got ax squared times c, and we've got dx on the bottom. So I need you guys to think. I'm going to go ahead and try to factor this out. What two terms multiply to give you ax squared and c? So what value was a? 2. And the value for c was negative 12. So we're going to multiply those together. So go ahead and multiply those together, and you get what? Negative 24. Go ahead and put x squared though. Everybody with me so far? Yeah. All right, what's the term that goes on the bottom? Negative 5. And put an x there. Now, does everybody agree that x times x will give you the x squared? And whenever you're adding x's, they give you still x's. So now all you got to do is figure out what are the two numbers that multiply to give you negative 24, but when you add, give you negative 5. So do me a favor, take a minute right now and try to do some multiplications of numbers. And then add them. Do they multiply to give you negative 24, but do they add to give you negative 5? So take a minute right now to see if you can figure that out. If you have it, go ahead and fill those in right here on the sides for me, okay? Now, for those of you that remember this already, that's good, because then this part is very important. That some of you might need this for reviews, because some of you guys don't remember this. That's okay. Now I'm going to give it okay. So here's what you need to remember. You need to remember your times tables. But you guys have graphing calculators, so remember that factoring is setting up a multiplication. So for example, 25, factor 25 out, that's 5 times 5, right? So in the times tables, what numbers will multiply to give you negative 24, but when you add them, give you negative 5? Yvette, what did you do? Negative 8 plus 3. DeAndre says yes. Sandra? Yes? Yes? Okay. Does it matter where I put the negative 8 and where I put the 3? You could have put the negative 8 on the left and the 3 on the right. Or vice versa. Switch. Okay? Now, before I do anything, does everybody understand what should have been done on the side of your paper or somewhere was you check, well, negative 8 times 3 is negative 24. Negative 8 plus, or positive 3 plus a negative 8 is a negative 5. That's something that you either did in your head or you did on the side. Yeah? I'm showing you that that is true though. Yeah? Okay? So I'm going to go ahead and leave that there for right now. So now what I want to do is, well, then the next rule is to set up the equation with your ax squared plus your question mark x plus your question mark x plus c. Okay? So after you figure this out, you're going to set this up. And the two middle terms, it doesn't matter where you're going to place them. Okay? So let's go ahead and set this up. Does everybody agree that the ax squared term is 2x squared? All right. So that's 2x squared. And what's one of my question mark x's?
Negative 8.
Negative 8. Could I put the 3 instead first?
Doesn't matter.
Doesn't matter. Let's just put the 3, just throw it off, yeah? Since I put the negative 8x over here first, right? Okay, let's just put the 3 over here. And don't worry, if you put the negative 8x right there, that's fine. We're still going to get the same thing, okay? Then we'll put the negative 8x. And then what's the c value? Negative 12. All right, and then from here, you're going to do factoring by what is called grouping. All right, so this is kind of like your general rule, your playbook that you're going to use so you can do the problem algebraically, okay? Some of you guys, is this coming back to you now? Yeah? Okay. Alright, so does everybody see that it didn't matter if I put the 3x or the negative 8x first here? Alright, do these two together plus these two together. And what you're going to end up doing is, what do these two have as a GCF in common that you can take out?
An x.
They both have an x. The coefficients are 3 and 2. So the factors of 3 and 2 have nothing that can be taken out. So the only thing we can factor out is an x. What's left over with the first term then? Just a 2x. And here's how you check. X times 2x, does it give you the 2x squared? Yeah? Okay. Plus, what's left on the second term?
3.
Just the 3. X times 3 is the 3x. You notice that if you were to distribute this back in, you should be able to go backwards. With me? Okay. What about these two? What do these two have in common? They both have a negative. And you say a 4. When you factor out a negative 4, it's almost the same as dividing by negative 4. Remember that. Remember, I'm going to tell you guys these 4 things. Add, subtract, multiply, divide. That's all we're doing this whole year still. Okay? So, you notice that the rules of multiplication and division are the same. So if you're multiplying, you're really dividing by something as well. Okay? Alright, so what do you, when you factor out a negative 4, what's left in the negative 8x? 2x, so just check. Negative 4 times 2x, does it give you a negative 8x? Okay, if it doesn't, then you're factoring something incorrectly. Yeah? Okay. All right, now factor out a negative 4 from negative 12. What are you left with? Just a positive 3, right? So you have to make sure you put a positive 3. Anybody notice that there's a 2x plus 3 and a 2x plus 3 on both of those terms that are in common? Factor that GCF and put it right here. What's left over that I haven't touched? And the negative 4. Remember, one of the answers was what? Remember, one of the answers was 4, 0 on the x-axis at 4.
How do you get the x minus 4?
There's a rule that says when you factor out a problem, let each parenthesis equal 0. That's called the 0 rule for factoring. Let each parenthesis, now notice in this parenthesis there was an x minus 4. When I let it equal 0 and I solve it for x, I have to add 4 to get the x one. And that'll give me x equals 4.
I don't understand how you got the x minus 4 to begin with. Like, did you?
Oh, that's what was left over. You notice that 2x plus 3 and 2x plus 3 were in both of these terms?
So those cancel out.
No, they don't cancel out. We factor them out again. Remember the same way we factored out the x from 2x squared plus 3x?
Mm-hmm.
What we did is we did two factorings. First, we factored them to put them in groups. Then after we put them in groups, they'll typically have something in common, which is called your GCF, or your greatest common factor. That they have in common, we factor it out, and what's left over is our other parentheses of x plus a negative 4, or you could just say x minus 1. The other parentheses, which is 2x plus 3, those of you guys that were here at the beginning of class, do you guys remember when we looked at the graphing calculator? Remember that x-intercept on the left? That decimal value wasn't exact, right? Well, that's because the x-intercept over there, again, you notice I set the parentheses 2x plus 3 equal to 0. That'll give me 2x equal to negative 3. Divide by 2. X is equal to negative 3 divided by 2. Guys, can you do negative 3, or can you just do 3 divided by 2 on your calculator real quick, see what decimal you get?
1.5.
Say it again.
1.5.
Negative 1.5, right? Remember the graphing calculator? It was almost right at negative 1.5, but did you see that the y value wasn't at 0 yet? So what we just did is we found the x-intercepts one way right now. You notice when we used the graphing calculator, it only gave us one of them exactly. Right now we just got both of the x-intercepts at negative 1.5 on the x-axis and at positive 4 on the x-axis are the x-intercepts. Those are called your zeros, your roots, your solutions, your x-intercepts. Okay? So if a problem that has a quadratic equation in it and it says, what are the zeros, the roots, the solutions, or the x-intercepts, they're all saying the exact same thing. Okay? Now that's one method that you guys can use to solve for a quadratic. So let me just kind of go backwards real quick. So factoring, does everybody understand, is setting up some type of a multiplication? And don't forget this part, to get the y-intercept, let x equals 0. To get the x-intercept, let y equals 0. Make sure you put that on your notes. Always, you can always refer to that worst case scenario, okay? And does everybody see that here is my playbook to help you guys set up. And then after you do factoring by grouping, you're just going to finish off with 2 sets of factoring out. And at the very end, you should get a parentheses, 2 parentheses that are set up as a multiplication. Okay? All right? For those of you that came in late, you're just you're going to have to make sure you go back and review the beginning of this. Now let me show you something. The parentheses that we got is 2x plus 3 and x minus 4. Everybody agree? That's the parentheses we just got. Can I check to see if that is correct? That gives me the 2x squared minus 5x minus 12. Well, I'm going to show you how to check it. using the box method. Two terms are in the first parentheses. Everybody agree? So I put 2 on the top. And 2 terms are in the second parentheses, right? X times 2x gives you 2x squared. X times 3 gives you 2x times negative 4x is, and negative 4 times 3 is negative 12. This, now that I just filled in, is my box method. Are there any terms that are x squared other than 2x squared? Okay. Are there any terms that are just x? Yeah, negative 8x. Those two are similar terms. They give you negative 5x, yeah? And then the constant, there's no other constant. Is that what we originally started with? Yeah. Okay. So when I'm doing my X box method, the box method is to check and see that your factoring was done correctly. Okay. Now it did seem like it was a little bit tedious, but you guys got to remember I was kind of reintroducing it to some of you guys that might have forgotten it. Okay. Yeah. Now, is this the only way to get the x-intercepts, this or the graphing calculator? There's actually another way to do it. Okay? So put in your notes. Quadratic formula. And this is on your graph paper that I gave you guys, quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. If that is incorrect in any way, I'll have to go back and double check it, but I'm almost positive that that's the correct formula. We'll know in a second if that's the correct formula, because when I substitute, if I don't get those values, then I know something I set up the formula wrong. But I'm pretty sure that is the quadratic formula. Do you notice that you have to be able to identify the A, B, and C terms from the quadratic equation though? A term is 2, B term is negative 5, and C term is negative 12. Does everybody see that? It's on the top. Go ahead and plug those values in. Okay, take a look at my substitution. Go ahead and evaluate that and try to simplify that if you can. I'll give you one more minute. All right, hopefully you guys made an attempt to simplify, and don't worry, if you end up getting something wrong, that's okay. We're just practicing right now. So practicing making mistakes right now is okay. We'll fix them. But here's my suggestion though. Don't erase any of your work. Just X out the minute that something's wrong and start writing down the correct steps when I'm doing it, okay? Everybody ready? All right. So do you guys remember you're going to have to follow this? Now here's the thing. Notice there's stuff on the top of the fraction bar and then there's stuff on the bottom. Do everything on the top and then do everything on the bottom. And then once you get in one number on the top and one number on the bottom, keep in mind though right here, does everybody see that it says plus or minus? That means there's going to be two answers on the top, okay? Divided by one thing on the bottom. So there's going to be a total of two answers when we finish, okay? Does everybody agree that a negative 5 is a positive 5? And that plus or minus there, I'm going to keep it a different color because I need you to remember. When you finish the square root, whatever you get as a square root, you're going to add it to 5, and then you're going to do 5 minus that number. Yeah? Okay. Inside, does everybody see that negative 5 is squared? That's a 25, right? Help me out here. Negative times a positive times a negative is a positive, isn't it? Yeah. 4 times 2 is 8. 8 times 12, help me out. What is it? 96. Does everybody agree? 96? Yeah. All right. In there, on the bottom, 2 times 2 is 4. Everybody okay right there? Can't add the 5 with anything or subtract it yet. You need to take care of the radical. Okay? So that's 5 plus or minus square root of, what's 96 and 25, guys? 121? Yes? Okay, I like that number. 121 is a nice number, yes? It's a perfect square, isn't it? Yeah. All right, before I do anything, have I lost anybody yet? Or if you guys didn't get to these steps, remember, when I'm giving you guys time to do work, this is where you guys have to practice. If you mess up, who cares? I'm going to go over it right away. That's why you practice. Messing up is fine, okay? 5 plus or minus, is that right, 11? All of it over 4. So now there's two answers. Does everybody see? One of them is 5 plus 11 divided by 4. And the other one is 5 minus 11 divided by 4. Yeah? 5 plus 11 is 16. Oops. Almost put 15. 16 over 4 is 4. One of the answers is x equal to 4. The other answer is x equals to 5 minus 11 is negative 6. Negative 6 divided by 4 is negative 3 over 2, which is, isn't that negative 1.5? Do 6 divided by 4 in the calculator. 1.5, right? So it's a negative then. You notice those are the exact same answers that I got when I did the factoring. Now, really important, you guys remember when I tell you, okay, you guys try to practice it, who cares if you get it wrong? Just try. Just try. Because it doesn't matter if you mess up. I'm going to go through it step by step, and the minute you did something that I didn't do, that's your red flag. Hey, ask a question because you did something that's different than what I did, or maybe I messed up. Yeah? Because if I messed up, just let me know. Okay? I don't think I messed up, did I? No, everybody agree everything was done correctly? Yeah? Okay. So, you guys see I got the exact same numbers? The other than when I factored it? Yeah. There is one other method. It's called completing the square. Have any of you heard that before, that term before? Completing the square is when you can't figure out the x method. Okay? Completing the square is when you can't figure out the x method. And maybe you're having trouble with the quadratic equation. Which one did you guys like right now? The factoring with the Xbox or the quadratic formula? Which one did you guys think? Which one did you think was easier from those two? You like the quadratic, you bet? You like the quadratic? Which one did you think was easier, Gary? Xbox method? Okay. Sandra, which one did you feel was easier for you? Xbox? DeAndre, which one did you think? Both are, either one, doesn't matter? Okay. What do you think?
Quadratic.
You like the quadratic? Okay. Kevin, what do you think? Out of the two methods I've shown, which one did you feel was easier? Doing the
I
Xbox?
feel like the quadratic is a little bit less work, but I like the Xbox method because it's more visual.
More visual? Okay. All right. So I've shown you two ways. I will get to the other one, the completing the square one. Okay? But for right now, those two should be your go-tos. Either that or you guys know how to use the graphing calculator. You can type in the equation. But here's the thing. You type it in the equation, you look at the graph, and you go to the table of values. You notice that the only x-intercept that we see, there is an x-intercept right here between -1 and -2, somewhere right here, but it doesn't show on the graphing calculator. Do you see the other x-intercept is right there, 4, 0? So if you use the graphing calculator, it may not give you both of them, or it may not give you any of them. Yeah? So putting it on the graphing calculator will be cool, because you can draw the picture of it on the test so you can sketch it. But what if you're supposed to label the intercept, because that's what you're going to end up having to do on the test? How do you do it if the graphing calculator doesn't give you it? Pick one of those two then. Does that make sense? Yeah? All right, so what I want you guys to do today, now you guys started looking at that handout that says a benchmark for Unit 2, right? When we finish Unit 2, we will have covered everything in that handout, okay? So do you notice right now, I want to focus on quadratic equation or factoring? Yeah? Okay. So can everybody do me a favor? I gave you guys a handout. This one, it says solve quadratic equations by factoring. Now, everybody, do you guys see that numbers 1, 2, 3, and 4 are already factored for you? How do you solve the equation if it's already factored for you? Let me show you what I did. If the equation is already factored for you, does everybody remember when the equation is already factored for you, use the zero product property, set each parenthesis equal to 0 to get your solutions? Yeah? So do you see how when I got the factoring of 2x plus 3 and x minus 4, I set each parenthesis equal to 0? Do you see that numbers 1 through 4, you're going to use the zero product property to solve for those? No? Okay. For numbers, everybody look at numbers 5 through 10. I want you to pay attention to numbers 5 through 10. Does everybody just take a look at them real quick, okay? On numbers 5 through 10, do you guys see anything unusual?
They're not in quadratic form.
You're kind of correct. DeAndre, you said something? The Y. The Y's not in there. Yeah? Technically, for number 5, oops. Okay. For number 5, the Y should be right here, shouldn't it? Or it should say f of x right there. instead of that -5. Or it should say it's just 0. So out of those three, can I make it be, can I get this side to have one of these three? Can it have a y, can I have an f of x, or can it have a 0? It can have a 0 there. How do I get the 0 to be on that side? What do I got to do with that -5? Add 5 to the other side, and that'll give me x squared minus 11x. 19 plus 5 is, 33 is 24. Does everybody agree now I got a 0 there? Whenever you got the equation and it's, does it have to be an x always? You notice that number 6 has ends. And there's ends. Over here there's r's. Do you guys realize that the letter is really irrelevant right there? As long as it's some letter squared. Yeah? All right. Once you get the 0 there, that 0 is also y, or it's also the same as saying f of x. Yeah? Now you can go ahead and either do the quadratic equation, or you can do the factoring. Yeah? All right. On the next page over here, everybody go to the next page, the back side of it. Do you notice that on number 11, you're going to have to just get the 0 there, so you know what to do with the -15? It's got 15 and you get your 0 there. Yeah. What about number 12? Everybody look at number 12. That one looks really weird. You subtract 11r. Okay. Now what do I do with that -30? Because it's still going to be on the right side. Add 30. You notice just get all the terms on the other side and combine like terms so that you can get 0 there, and then you can do your factoring or quadratic formula. Yeah? All right. Are there any questions then on what we're going to practice then today for the rest of the period? No? Okay. When you have questions on any of those, you guys can work with each other. I'm going to put the answer key right here so you can look at the answers, see if they're matching. And then those of you, if you're getting stuck, that's where I can work with you. Yeah? Any questions then? If you finish that handout very quickly and you're done and your answers all match, then you just make sure I see it before, and then you can leave. Yeah? All right, so now we've started Unit 2. Does everybody understand that first handout that says the Unit 2 benchmark? You're going to be finishing that handout as we're going through the lessons for Unit 2, though, okay? Any questions on any of those? We'll eventually, when I'm done with that, you should be able to do that benchmark on your own, okay? That benchmark, don't lose it, okay?